if f of x is cosine x multiplied by tan x, show that the derivative of this is cosine x. Okay, we will notice that this requires the product rule because we have two functions of x being multiplied by each other, cosine x by tan x. Let's call the first u and the second v. We're going to use the product rule. The product rule says that dy dx is equal to u times dv dx plus v times du dx. So applying this, the derivative f dash of x is equal to u, which is cosine x, multiplied by dv dx, the derivative of tan x, which is sec squared x, plus v, which is tan x, times du dx, the derivative of cos x is negative sine x. So this is our solution. This is the derivative. However, we've been asked to show that this is equal to cosine x. This requires a good knowledge of trigonometry. So we'd have to look up in the tables, page 13, and see some of the rules about trigonometry. So we would have to understand what sec squared x is. So sec x, if we look it up, is 1 over cosine x. So if cosine x is adjacent over hypotenuse, sec x is the opposite of that. It's hypotenuse over adjacent. Tan x can be expressed as sine x divided by cosine x. And it's going to be important in this as well that cos squared x plus sine squared x is equal to 1. And I'll explain that in a minute. Okay, so let's replace our sec squared x and our tan x with these terms. So we can write our derivative as cosine x being multiplied by 1 over cos x to be squared plus tan x, which is sine x over cos x, being multiplied by negative sine x. Now when we neaten this up, applying in the square, it becomes 1 squared over cos squared x, and cos x and cos squared x have a common denominator of cos x. So this becomes just 1 over cos x. We'll notice here the common denominator in both fractions here are the same, both are cos x. So I'm going to write this as a common denominator, cos x. So in the first fraction we just have 1, and the second fraction we have negative sine squared x when we expand it. Now, this will be familiar to students later on in the course that 1 minus sine squared x is the same as cos squared x. This is because cos squared x plus sine squared x is equal to 1. So if we took sine squared x from both sides of this equation, we'd see that cos squared x is equal to 1 minus sine squared x. So we could replace the numerator in this fraction as cos squared x. And that's been divided by cos x. And again, cos x divides into cos squared x, cos x times, giving the solution that the whole derivative equals cos x, and we've proven what we set out to prove.